All right, we're continuing on our exponential functions. So day 2, we're going to graph these exponential functions. And so to do that, let's see what we've got. It says graph the exponential function f of x equals 4 to the x power and identify its key attributes. So as we're completing the table on this, see if we do 4 to the negative 2 power, it would be, let's see, 4 to the second power. We'll go the other way. Starting with 0 power, we know that's always going to be 1. First power would be 4. Then 4 to the second, so 4 squared would be 16. So if we go back the other way, negative 1 then would be 1 over 4. And the negative 2 power would be 1 over 16. So looking at graphing that, for f of x, have it cross at 0, 1. And then we have 1, 4, 2, 16. And 3 would be way up off the map. Then at negative 1, we're at 1/4, and then 1/16. So we're really just getting really close along that line here. So just giving you an idea of how it's going to go, and we're going to do our best to take and trace that graph kind of around as it goes just to get a general idea. And so that's going to be our f of x. So looking at this, our a value, there's nothing out in front of this 4 being multiplied that doesn't have an exponent. So that means the a value is just 1. The b value, that's the base, it's going to be 4. Y-intercept on this, of course, was 0, 1. And that asymptote was y equals 0. It is going to be growth. And same as yesterday, our domain will still be all real numbers. And our range is that asymptote and decide whether it's going up or down from it. Since it's going up, y is going to be greater than 0. Okay, now we'll look at one that has that a value in the front. So if I do 2 times 4 to the x power, now when I'm at 0, it makes that 4 to the 0 power is 1 times 2 is 2. If I do 4 to the first power, it's 4 times 2 is 8. And then 4 to the second power is 16 times 2 would give me 32. Then when I go down to negative 1, I said 4 to the negative 1 power was 1/4 times 2 is going to be 1/2. And then 1/16 times 2 is going to be 1/8. So what we get there is a graph that's shifted up a little bit, but then goes back down to be really close to the same. So down here lower, we can't tell the difference, but the further we go up, we notice it more. So when it's at 0, it's at 2. At 1, it's up at 8. And at 2, we're all the way up to 32. So we'd be going something like that. Not a perfect drawing at all, but as long as we get the idea of where we're going, we're good to go. So that's why g of x. So on this one, I've got an a value of 2. B value is still 4. My y-intercept changed from 0, 1 to 0, 2. But my asymptote is still y equals 0. My domain and range then would also be the same. And so we can see, doesn't look like much difference there, but if you're talking about money and earning in 2 months $16 versus $32 on it, then yeah, that could make a significant difference there. So we'll look at a couple more examples down here just of what can happen if we multiply different things in these exponential functions. So I want us to graph if I do -1 times 4 to the x power. And so if I was at let's see, if I had x is 0, make a little chart here. If x is 0, then y would be 1, but it would make it negative, so it'd be a -1. If it's 1, that'd be a -4. And 2, that'd be a -16. Then if I had, then we can just get to, if it's -1 here, that'd be 1/4, so it'd be -1/4. And that should give us enough to kind of graph this here. So 0, -1. It's 1, it's at -4. And when it's at 2, it's at -16, which is down past where we could be. And then 1/4 there. So look like something like that right there. So my y-intercept here is going to be 0, -1. Asymptote is still y equals 0. This is decreasing because it's moving downwards. Domain again is going to be all real numbers. Then my range, that's 0, but all my y values are going to be less than 0 this time. So on this one, we'd be less than 0. And so if we look at this one versus my original function up here, it's about the same, just flipped over on that x-axis. Then for g of x, for my x and y values, if it's 0, then y is going to be 1/2. At 1, it'd be 4, and half of 4 is 2. And at 2, it'd be 16, and half of 16 would be 8. Then when I get to -1, it's 1/2 of a 4th, which would be 1/8. So graphing that on here, 0's at 1/2, then we're at 1/8 there. At 1, it's up to 2, and at 2, it's up to 8. And so, again, it doesn't just look hugely different, but this,
pardon this interruption, healthcare and
but this one is definitely going up slower than my original function. So y-intercept on this one would be 0, 1/2. Asymptote, still y equals 0. This one is back to being a growth. Domain remains the same. My range is back to y is greater than 0. Okay, so we've got a lot of differences here. We'll look at one more if we got time. So if I do an XY chart for the deal to the 1/2, still if I start out at 0, it's going to be 1. If I go to -1, it'd be 2, and -2, 2 squared would be 4. Now if I go to 1, and it's 1/2, and 2 would be 1/4. So get down to where this kind of is going the opposite way. So -1, it's 2. At 2, it's 4. And 3 would be up to 8. And then 16 at -4. So you can get a little bit more of a sense of the graph here as we're going up. So it looks like this one, but I've tilted it kind of the opposite way, and the curve is not as extreme. So y-intercept would be 0, 1. Asymptote still y equals 0. This is a decreasing one, so kind of flipped over or reflected on the y-axis, if you think of it that way. Domain remains the same, and range remains the same. Okay, my other one, when I've got it times 4, it'd go through at 4, and it'd increase a lot quicker. Don't quite have time to go through it now, but look, something like that, just increasing a lot faster as we go through. So you can put this in the calculator and make a table, use Desmos to get a few points, but when you're graphing it, as long as you got a few points to give you an idea of where you're going, you're good to go. Then you'll just be telling me a little bit of the information there on it.